Mr. Townsend?
Yes.
When you do sign me up for taking the quiz, is it possible to do Wednesday? Because I'm doing intramural volleyball and we have a day Tuesday.
I'm not supposed to, because Tuesday is the math priority day, but this one time I will.
Thank you, sir.
But,
I appreciate it.
well, you might have to remind me, because I will try my best to do it right.
Thank you.
Since you offered to take it early, I can be flexible.
Mr. Townsend?
Yeah.
I noticed that you marked me tournament on Wednesday.
Yep.
But I was here. I just took the bathroom pass.
No bathroom pass first 10 minutes or last 10 minutes.
Oh, sorry.
Yeah, that's a new thing. Read Mia. Smart. Colin.
See it.
All right, good morning. I need you guys to get out your bookwork.
Good morning, FHS.
Today is Friday, September 22nd, 2023. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you, everyone. Have a great weekend.
I'm also gonna have to leave at like 9:25.
It shows already.
Thank you. Just remind me next time. Alright guys, so last time I saw you, we took some notes on section 4.4 and tried to identify what looked a little bit different in this section. So still a lot of SOHCAHTOA, unit circle, all of that kind of stuff. We spent the whole class period on that, and then hopefully you guys went back for homework and tried the rest of it so you know what you need help with. So we've got 45 minutes of class here where I can take your questions and or you can study, and then the second 45 minutes we will take our quiz over this. So which questions did you have trouble with from the book assignment? Again, this section we didn't do a practice quiz like we did the first couple. We still do some others,
But it's not really a secret. Just like scanning through the assignment.
39. Scanning through the assignment, 9B, 11A, and 13 were the same type of questions, so there's probably one of those on the quiz. 19 through 22 are all the same type of question. There's probably one or two of those on the quiz. 33 through 36 were the same type of question. Probably one of those on the quiz. 47 through 54 were all the same type of questions. Probably a couple of those on the quiz. So we're not really keeping it a secret, but... Okay, 39. This is a unit circle problem. It wants, the way I know it's a unit circle problem is this is an angle that I have memorized on the unit circle. So if you go to 3 pi over 2, you think about the point at 3 pi over 2, you know what the cosine is there and the sine is there. And if you want secant, it would be the reciprocal of which one? Okay, and what is the reciprocal of 0? Undefined. Can't divide by 0. And that's the whole thing. Okay, is that enough there? Okay. Anybody else that's going to ask about 39? Want something more detailed before I take a different one? Okay. And again, I will take as many questions as we have time for in this 45 minutes, but y'all need to keep them coming. If you only have 5 questions, that's fine, but if you have 50 questions, I can only get to so many, so the faster you get to them, the more we get to.
We do 54.
Sure. Okay, 54 was one about a reference angle, and the angle we were working with was 12.9, and it doesn't say degrees, so that means radians. So when we sketch our picture here, again, the book says you need to sketch your picture. In your notes we sketch your picture. I'm pretty sure on the quiz it doesn't say you have to sketch a picture, but it's pretty hard to do otherwise. So I'm trying to do this without a calculator. I know this is 0 radians. This is pi radians, but this is not written in terms of pi, so I'm going to try to think of this as a decimal, 3.14. This is 2 pi, which is about 6.28. And actually, if I double that for 4 pi, that would be 12.56. So do you see how 12.9 is a little bit more than that? So it's like it's going around one time for 2 pi, a second time around for 4 pi, and then the angle is a little bit bigger than that. So I have to do it good enough to know that it lands in quadrant 1. Draw the line to the x-axis to get your right triangle. This is the reference angle that we'd like to know. So I can see that I turned 12.9 radians. And the amount of that turn that was not the reference angle, just this last little bit, was all of this, which is 1 rotation, and all of this, which was a 2nd rotation. So take away 2 rotations would be subtracting 4 pi, and there's no need to round or get a decimal. That's a better answer there. So I think that was probably the hardest of those 8, but are you okay with how I figured out this was in quadrant 1?
Yeah, that's what I got.
Okay.
You do 52.
52. Okay, another one of these. This one, the angle is 7 pi over 6. Now this is a no calculator quiz, so there's nothing stopping you from converting this to degrees. It's a little harder to do by hand than with the calculator, but any of the calculator needed stuff, we rephrase the questions where you don't need a calculator. So this is the same as this, or you could just know what 1 pi over 6 is, get to 2, 3, 4, 5, 6, 7. Enough to know that it's down here in quadrant 3. Take your point and draw it to the x-axis to get your reference triangle. And then this is the reference angle that we're interested in knowing the size of. So similar to the last one, there's a length and angle measure that I know, like 7 pi over 6. And the amount of it that is not the reference angle is this stuff. And that stuff happens to be exactly pi. Change it to a common denominator, and you should end up with pi over 6. Reference angles are always acute and have to be positive. If your answer is bigger than 90 degrees or bigger than pi over 2 radians, there's no way it can be correct. And if your answer is negative, there's no way it can be correct. So just use that as a quick check. All right, Colin, was that enough there?
Yeah.
Anybody else that's going to ask about 52? One more chance before I take something different.
I have a question.
Sure.
Can we, so if we get something, so you got pi over 6,
Mhm.
can we also answer it in terms of degrees?
No. Generally in math, if the question is given to you in radians, it's expected that your answer is in radians. Now you can do it in degrees, get an answer of 30 degrees, and then as long as you change it over before you circle your answer, that's fine.
Okay.
So if moving it to degrees makes the question easier for you, go for it. But starts in degrees, your answer should be in degrees. If it starts in radians, your answer should be in radians. Okay, somebody who's not had a chance to ask a question, I'll give you a chance before others get multiple questions. Okay.
73.
73. Okay, 73 gives us one trig value, cosine. It tells me that my reference triangle is in quadrant 1. And really, to me, this is a lot like question 25. But on question 25, you had to find all 6 trig values. This one, you really only need one answer. There's one answer that it's looking for. So this should tell you what your picture should look like. Draw your triangle somewhere in quadrant 1. Because of SOHCAHTOA, we can label 5 as adjacent and 8 as hypotenuse. Now the hypotenuse is always positive because we just care about its length. But you do have to be careful here. If this was going left instead of right, this 5 would need to be negative. Although I guess this would be negative too. So, but to know which one it goes with. Likewise, when I do Pythagorean theorem to find this side, Pythagorean theorem is great at determining that length, but he has no idea if I was trying to go down. So I'd have to have be paying attention enough to know that it's going down and I need to make it negative. Let's see, 64 minus 5 would be 59, so minus 20 more would be 39. Okay, so this would be 3 times 13, which doesn't break down, so square root of 39. But again, it's positive square root of 39 because it's going up. And then cosecant is hypotenuse over opposite. And then after you rationalize, it should look like that. So again, very similar to question 25, but instead of wanting 6 answers, it just wanted the 1 answer. Now, if we keep in mind this all students take calculus stuff, this angle was in quadrant 1, bless you. So every trig function is positive in quadrant 1. So this answer better be positive too. If for some reason you thought it was negative, you need to look for your mistake. Okay, is that enough for 73? Anybody else that wanted to ask about 73? Okay, somebody else who's not had a chance to ask yet today. 93. 93 has 2 parts. Oh, I'm looking at the wrong one. It says cosine is 1/2 and secant is 2. We did this type of question, just 1 or 2 in the previous section, but you weren't quizzed on it yet. And it says, figure out where this happens. Give 2 answers in degrees and 2 answers in radians. Okay, and this is what, and it says between 0 and 360 and 0 and 2 pi. So just in one rotation, there's 2 places where this is true and there's 2 places where this is true. So to me, this is still a unit circle question. It's just kind of backwards. Instead of telling you the angle to go to, you find the angle, you think of the point, you get sine and cosine out of the point, and then you give this type of answer. We're telling you cosine's 1/2, and you got to think about, if I went around the unit circle, where's cosine 1/2, or where's the x values 1/2, and that occurs here at 60 degrees and here at 300 degrees. 60 degrees is the same as pi over 3 radians, and this is the same as 5 pi over 3 radians. So this is the answer to part A. Part B, I don't memorize secant values, but I can take the reciprocal of both sides. The reciprocal of secant is cosine, or reciprocal of 2 is 1/2, and as soon as you do that, you realize it's really the same thing as part A. So you get the same answer for part A and part B. But it's asking you what angle makes that true. So it's still a spot on the unit circle, but again, instead of you being told where to look at the angle and then you find the ratio, it's telling you the ratio and asking you to go and find the angle. But you still got to know the unit circle. So when I told you guys we did unit circle all semester, I'm sure you're starting to believe me, but it's not always framed the same way. Like 39 to me is pretty straightforward unit circle question, but this you may not have realized it was unit circles. But throughout the semester, about any different way you could look at a question, or look at the unit circle as ways we try to approach it. The more ways we think about it, the better we understand it. So, okay, is that good enough for 93? Okay, anybody else that was going to ask about 93? Because again, I'll work as many questions as we have time for, but I'm not going to work the same question twice. That wouldn't be fair for everybody else. Okay. Somebody else who's not asked a second question yet? Or a first question? Yes, Lucas.
97.
97? Alright, so this one is about the airplane. There's a guy standing down here. There's a distance between him and the airplane. Sorry, that's as good as my drawings get. And we know the altitude of the airplane is 6 miles. We would like to figure out how big is this angle, or no. We want to figure out what D is. How far away is the plane from the person if this angle was 30 degrees? So from a SOHCAHTOA equation, we could say from 30, we have opposite and hypotenuse. SOHCAHTOA tells me that sine, always opposite over hypotenuse. After you finish solving it, it looks like this. And just because this happens to be an angle I'm familiar with, I know what this is without a calculator. Sine at 30 degrees is a half, and dividing by half is like multiplying by 2. So if that plane has an altitude of 6 miles, and you're looking at it with a 30-degree angle, your distance from you to the plane would be 12 miles. But then part B says, well, what if the angle was at 90 degrees? So if this changed to 90 degrees, the plane's straight above him, so how far is the plane away from the person then? Yeah, still 6 miles. And then part C, what if the angle changed to 120? So now you're looking back here over this way. Now the airplane's over here. Well, we could do, if this is 6 miles, this would be 6 miles. If this is 120, and this much of it's 90, this much of it would be 30, which means this much of it would be 60. Notice I'm basically finding the size of a reference angle, which is why that's a good skill to have. And then if I want to know how far away the person is from the plane now, I know opposite, and I would like his hypotenuse. So that's still sine opposite over hypotenuse. At 60 degrees, sine is square root of 3 over 2. Okay, this is saying the same thing as this. This is a vertical format, this is a horizontal format. Usually the horizontal format's a little easier for y'all to see what to do. Looks like we end up with 12 square root of 3 over 3 miles. That would be the exact answer. And it didn't say anything about rounding, so I'm going to assume not to round.
You simplify it.
Oh, yeah, you should. Should do 4 square root of 3. Now, of course, if this was a real life question, you'd probably want to know what the decimal was. It's about 6.928 miles. I'm not going to circle that as my answer because it didn't ask me to round, but it just gives you an idea. If you know how far the plane is up in the air, you know the angle, you can determine it's 12 miles away, but then when it's directly above you, it's the same as the altitude, 6 miles away. And then if you had to turn back another 30 degrees, it ended up being about 7 miles away. So knowing just really the plane altitude and the angle from the ground, and you can calculate your distance to the plane. Okay, Lucas, was that your question? Okay. Is there something more specific in there?
Why did you do 60 degrees instead of 120?
Well, I just went around and I just started looking at this little triangle here. But the sine of 60 degrees and the sine of 120 are the same, so it didn't matter. It's just that 120 didn't really make sense with my picture. It was why I kind of kept going and showed where you would be looking that direction. Okay, anybody else on this one? Okay, and then I guess we're still on anybody who hasn't asked a question yet. Okay, anybody who has asked a question then? Got more? 95. Okay. So these are the backwards unit circle questions. Again. Okay, so this one wants me to give two solutions to this. There's 2 times that tangent is 1. If you do 1 rotation. They want the answer in degrees and radians. And there's 2 times cotangent is negative square root of 3 if you make 1 rotation around the circle. But we'll just worry about part A first. So if we think of tangent as, again, when we memorize the unit circle, we're really memorizing a bunch of sine and cosine values. Tangent, though, I don't memorize tangent, well, I do memorize tangent values, but tangent is sine over cosine. So when is sine divided by cosine going to be 1? When they're the what? When they're the same. So that's a big hint. You start going around the unit circle, they're certainly not the same here, they're not the same here, but they are the same here. They're both square root of 2 over 2. You keep going, and eventually there's one more time they're the same. They're both negative square root of 2 over 2. So one answer is here, 45 degrees, pi over 4 radians. The other answer is down here at 225, which is 5 pi over 4 radians. Now, I found those 2 locations maybe a little bit quicker than you did, but I'm just pulling on my memorized unit circle. Are you okay with that one? Okay. This one's a little bit harder. The tangent 1's just a nice number. That's why it's not too hard to figure out where 1 is. But I certainly don't memorize cotangent values. So what I would start off with is taking the reciprocal of both sides and then rationalizing this to make it look more familiar. Now, you probably don't know where tangent is negative square root of 3 over 3. But it shouldn't be a total goose hunt. Why should I know that it's not going to be in quadrant 1? I should not try anything in quadrant 1. Perfect. Because in quadrant 1, all the trig values are positive, and I want to find an angle that has a negative tangent. So don't waste your time testing quadrant 1. Also, what other quadrant is tangent going to be positive in? 3. So any point you tried in quadrant 3 would be a waste of time, because tangent and his reciprocal are positive in 3. Hopefully you realize that in the middle of these quadrants, kind of like the last question, sine and cosine are the same, except one's positive and one's negative. Something divided by itself is going to be 1, but in this case one's positive, one's negative. So that really leaves 2 options to try. So at some point this semester, I will recommend that you memorize the tangent values so that you don't have to do this to yourself. But for now, what you have to do is you just have to guess one of these. Think about sine and cosine, and then force yourself to see does sine divided by cosine, does it give me what I want? Then that's one of my answers. If it didn't, if I had tried this one first, it would have been negative square root of 3, so that wouldn't have been what I wanted. And I would have had to just try something else. So 330, which is 11 pi over 6, is this answer. And you can do the same things over here. You can guess and check this one, do sine divided by cosine, see that it doesn't give you the correct tangent value, then try this one and do sine divided by cosine, and the one that you will want is this one. So I don't know if I've told you guys this yet, but a nice thing about tangent values is they're always exactly the same thing directly across from the circle. So what I mean by that is if tangent here is negative square root of 3 over 3, directly across the unit circle has the same tangent value. Directly across, same tangent value. Directly across has the same tangent value. Directly across has the same tangent value. Directly across, directly across. So if you know that, you really only have to find one of them, and then the other one's directly across from it. Now, I guess later on you might, the other answer then, so was 150, which is 5 pi over 6. And again, what makes this one harder is I had to change it to a tangent question, so I was a little more familiar with it. I had to think about where tangent would even be negative so that I wouldn't waste my time in 2 of the quadrants. And then there's 3 points to try. Try one, do sine divided by cosine. If it's not what you want, try another one. Do sine divided by cosine. If it's not what you want, try the other one. Eventually, sine divided by cosine is going to give you what you want. And if you can find that, directly across from it would have the same tangent value, so it would also have the same cotangent value. Now, I'm going to give you the real quick version because you're probably not convinced that it's worth the effort to memorize tangent values. But honestly, there's only 3 tangent values that show up a lot. In the middle of each quadrant, you get 1 or negative 1, depending on the quadrant. This is all about tangent. You've got the points near the x-axis that are always square root of 3 divided by 3. They're smaller. But again, depending on the quadrant, it might be negative. And the only other tangent values from angles we memorize on the unit circle are these by the y-axis, and they're bigger because they're not divided by 3. They're just square root of 3. But again, depending on the quadrant, it could be negative. So, in the middle, tangent is 1 or negative 1. The values around the x-axis are square root of 3 over 3 or negative square root of 3 over 3, and the values around the y-axis are square root of 3 or negative square root of 3. So, it's saying to memorize all the tangent values around the unit circle sounds like a lot, but again, there's really only 3 different values. So eventually you will be convinced that that's worth it because it makes questions like that a whole lot quicker. There's no guess and check involved once you do that. Okay, Colin, was that yours? Okay, that's good. All right, anybody else on 95?
Have we already done 53?
We did not. Okay, and it looks like we got about 15 more minutes before we need to start. Oh, 53. Well, did you check in the back of the book? Okay, that'd be the quickest way. I would say since pi is right here, that pi as a decimal is about 3.14. 4.8 is definitely bigger than this, but I'm a little bit worried it might be in between these. So 1 pi is 3.14, 2 pi would be twice that, and boy, I don't know, the average of those, trying to do this without a calculator, would be or adding them together would be 9.42. And then the average, divide that in half, would be 4.5 plus 0.2 plus 0.01, 4.71. You see how I'm figuring out what's in the middle of those? So that's what I was concerned about. 4.8 is just a little bit bigger than 3 pi over 2. Again, if you have a calculator, you just put 3 pi over 2 in your calculator to get that decimal. So the reference angle you're trying to find is right here. And so I would say I almost went all the way around 2 pi, but I didn't. None of this is part of the reference angle, and that much of a turn is 4.8 radians.
I did K.
Okay. And that's it.
I did it in my
Don't-
math.
Well, without a picture is very risky. I'm not saying that you can't do it sometimes, but it's pretty tough. Now, this will be no calculator, so of course you can't get it to a decimal, and it doesn't ask me to round. There's no sense in, I don't know why you guys love to put them in the calculators and get decimals. That's more work. This is the better answer. And it's less work. Okay, keep going.
You do 79.
Sure. Okay, 79 is a calculator question, and I told you guys that it would be no calculator. So it's not that this won't be on there, it just will be phrased in a way that you won't need a calculator. So it says use your calculator to evaluate this. I would say the most common mistake would be sometimes you guys like to do like something like this. But inverse functions are for finding angles. I know what the angle is. I want to know the ratio. So the best thing that you could do is, if your calculator doesn't have a cotangent button, you have to do 1 over tangent, because that's the same thing as cotangent. And you would need to make sure your calculator was in degree mode. But this is what you should put in your calculator. So this is what we'd want you to answer on the test or the quiz, but I guess in the book it asks for 4 decimal places. So that's probably what they get. And you have to do that for secant and cosecant or cotangent. You've got to use their reciprocal identities to be able to type it in. Okay, 12 minutes left. Give another chance for anybody who hasn't asked the question yet today. 54. We already did 54. Yeah, Lucas. Okay, 40 wants to know the secant value at pi. So because pi is a unit circle spot, this ends up being a unit circle question. You need to know where pi is on the unit circle. You have to know what the point is at pi. So that way you know the cosine of pi and the sine of pi. And secant is just the reciprocal of cosine. So if cosine's -1, you flip -1 over, you still get -1. Again, it's a lot like what you guys did in section 4.2 with unit circle, but instead of answering all 6, sine, cosine, tangent, secant, cosecant, and cotangent, it's just asking for one of those, a specific one. It only wanted the secant answer. Okay, about 10 minutes left. No more questions? Okay, then you're welcome to use these 10 minutes to scan through your book assignment. Just as a quick refresh, a quick study before the quiz, which of course normally you'd have to do before class. Yeah, as long as it's not. Oh, she still has a pass. She should be back in a second though. I forgot she was out. As long as it's not the first or last 10 minutes, I'm not picking.
Early trip.
9:30, 9:25. Okay, thank you. Let's see. Hadley, are you in band?
I had to help with the pep rally, but she said I could come and take the one.
Okay.
So I just have sole business.
Okay, you're fine. I know some of you guys will have to leave here shortly, and so you won't get to the quiz today. I will put you in prime time for Tuesday to make it up. Aiden, don't pass it quick. Huh? All the vocab check is always a page or two before. I think all of those are right here. Also, if you have to leave early for the get ready for the pep rally today, I will leave it up to you whether you want to leave your homework assignment with me. If you leave your homework assignment with me, I can get the grade put in, but then you don't have it to look over between now and Tuesday to refresh yourself. But if you keep it, you'll need to remember to turn it in before you start the quiz on Tuesday. So it's a trade-off, but I'm fine with either one for those of you that have to leave early. About 6 more minutes, and then we need to start to make sure you have time.
We need to get started in about 2 minutes. So if you are ready, you're welcome to bring me your, I guess that was only taking 21, sorry. You can come put your book assignment in the basket. I don't need your notes. I changed my mind this time. And you can put your phones and smartwatches away. And then I'll get you the quiz. Again, this quiz is no calculator. All the calculator type parts have been reworded where you don't need a calculator. You can do it Tuesday during advisory. You won't have time to do it now because you've got to leave in like 10 minutes. Now I changed my mind. Sometimes I get one for the notes and sometimes I don't. Make sure y'all put your calculators off your desk. I don't want you to momentarily forget there's no calculator and then get a 0 on it. So put it under your desk or whatever. Yeah, if y'all are leaving in like 10 minutes, and so you can't take the quiz today, you're welcome to just sit on your phones or get on your Chromebooks or something productive. Okay, please put your name on it and number as number 22. This quiz is number 22 in your Bible.
switch the main screen over to the dismissal timer. So that's how much time you have left for your quiz. And then one other thing real quick, I'm sorry to interrupt, but normally most of you guys don't turn in a hard copy of your homework, but if you guys don't pick these up today, then I could end up having them for weeks, and I want you to have them in your binder. So when you come pick your phone back up, the stack of papers that you just turned in to me will be on this chair right in front of them. Just go through there and take yours out so that you have it back. So just pick up your homework when you get your phone. You're good. Go ahead. Yeah, if y'all need to leave early for the pep rally, now's about the time.
checked your work?
Yeah.
Okay. Just making sure. That's it. In the basket. Thank you. Again, when you guys finish, grab your phones, grab your homework back, and you don't have any homework or anything, so just find something quiet to work on, preferably something productive for another class. Thank you.
Mr. Townsend, since I'm finished, can I go to the pep rally?
Yes.
Thank you.
Don't forget your phones and your homework. those of you still working, you still got over 15 minutes. So, no rush. Those of you still working, you're down to 5 minutes. So, y'all got about 4 minutes to yourself, but you're welcome to visit quietly now. As always, the grades will be in by the end of today if they're not in already, but you'll have to wait till everyone has a chance to make them up before I can let you see yours. Just in case you didn't see the notice in RTI scheduler, they do expect you to go to your advisory before the pep rally. That's how they'll take attendance. So don't go straight to the gym. You'll need to go to your advisory first.